Today we'll discuss how mean, variance and standard deviation for the binomial distribution is calculated. I have already told you that every distribution has a mean, variance and standard deviation. So for in case of binomial distribution, the mean can be easily calculated as a product of the probability and total number of trials, and the variance can be calculated as a product of number of trials into probability of success into probability of failure. And same is the case with the standard deviation. Once you know the variance, by just squaring the variance, you can find out the standard deviation. So we can take an example. For example, that a coin is tossed 4 times. Here n is 4. Find the mean, variance and standard deviation of the number of heads that will be obtained. So how can you calculate the mean, variance and standard deviation of the number of heads? So definitely, as you know, that's the case of binomial distribution. It can be easily calculated with this formula n into p. As you know that 4 is the number of times this experiment was run, and half is the probability of success. So it's total 2. As far as standard deviation is concerned, it's n into p into q. So here the product of n into p into q is calculated, and probability of success is multiplied with probability of failure, and it is then multiplied to the total number of trials, right? So it would be 1. Same is the case with an example of rolling a die. A die is rolled 360 times, and you know that its probability can be calculated using binomial distribution. So find the mean, variance and standard deviation of the number of 4s that will be rolled. How you can do this? So you should know the probability of success and you should know the probability of failure. So in this case, getting 4 is a success and not getting 4 is a failure, and you know the probability of both. Okay, getting 4, probability of getting 4 is 1 upon 6, and probability of not getting 4 is 5 upon 6. So an average of 60 4s should be calculated or should be there, but when you actually rolled it, so when you will count that how many times you have 4 in your experiment, so you can easily find out, right? You should get an average of 60 4s in your values, but definitely if you have 50 students in your class and 50 students rolled it 360 times, so there is bright chances that not all of you got 4 60 times. Some of you may have it 50 times, some of you may have it 60 times. So definitely there must be some variation. So what is that range of that variation? So that deviation is actually calculated here. So this could be written as 60 plus minus 7. So if you make it a range, so ये जो range है इसका मतलब है कि ये 53 60 में से 7 हम माइनस करेंगे तो ये लोअर रेंज 53 है, और 60 में 7 प्लस करेंगे तो अपर रेंज 67 है. So all of you, almost all of you will have your count of 4 within this range if you have rolled it between 360 times. Means the range of lambda plus minus deviation. ठीक है, आपकी जो भी वैल्यू हो वो इस रेंज में आनी चाहिए, इस रेंज में आनी चाहिए. ठीक है, so on average 64s will be rolled, but definitely everybody will have some slight variations. Definitely this standard deviation is also calculated, that to which extent it should variate. So for example, someone has a value, for example 75 4s, right? This is a possibility, it can happen, right? But what if all of you have the number of fours within the range of 70 to 80. ठीक है, it means that in that case your die is not fair. ठीक है, आपका डाई जो है वो या तो फेयर डाई नहीं है, या वो कोई बायस डाई है, या वो कहीं से घिसा हुआ है, जो कि जिसकी वजह से जो है ये जो 60 के बजाय बहुत ज़्यादा नंबर आ रहा है, राइट। तो इस तरह से हमें किसी भी डिस्ट्रीब्यूशन का मीन वेरिएंस से हमें पता चल जाता है कि कोई भी वैल्यू कहाँ ऑन द एवरेज लाई करेगी। नाउ यू कैन ऑल्सो चेक दैट another example, the likelihood of twins. Okay, so as you can see that there is a data that is expressing this statistics that 2% of the all American births they result in twins, right? So if they have taken the sample of 8,000 births, find the mean number of and variance and deviation of the number of births that would result in twins. So how many times it can result in the occurrence of twins? So definitely it's a binomial situation, because a birth can result in either twins or not twins. So the probability of twins is the probability of success here, which is the 2%. So 2% and is expressed over here in total number of sample is 8,000. So on the average 160 out of 8,000 out of 8,160 births should result in the twins, right? And if they have taken the standard deviation by simply calculating n into p into q and its root, it's 12.5. So on average, out of every 8,000 births, it should be the case of 160 plus minus 12.5. Right, so the number should be within this range, right? As you know that it's 12.5, it's not the case of the twins. You cannot calculate the twins in terms of points. You can round it up to 13, or you can round it up to 157.